Hi and welcome to my YouTube channel. If you're new here, there should be a little button down below that says subscribe. Please click on that button for vibes. In today's video, I'm going to show you how to use a rotary encoder with an STM32 microcontroller. My name is Ali and you're watching CGHQ. Let's start our project by opening STM32 IDE and clicking on create a new STM32 project. Then go to board selector and type in the microcontroller that you have. Then click on the microcontroller and then click on next. For the name, we can just call it encoder or anything that you would like. Then click on finish. We are going to initialize everything ourselves. So just click on pin out and then click on clear pin out. Then go to system core and then under system, click on serial wire. And then go to RCC, click on the high-speed clock, and then enable the crystal ceramic resonator. Then go to clock configuration, and then you can just make sure that your microcontroller is running at its maximum frequency. Then go back to pinout and configurations, and then go to timers. And then before we can initialize our timer, we can just quickly go to the datasheet of our microcontroller and then search for encoder. When the results pop out, we see that the general purpose timers 2, 15 and 16 support the encoder functionality. So we can choose any of these timers to read our rotary encoder output. We can then go back to our IDE and then click on timer 2. And then here where it says combined channels, we're just going to click on encoder mode. And then before we can change the parameters here, let's go to this picture here. On this picture, we see that our rotary encoder has a counter that is able to count both up and downwards based on whether you rotate it clockwise or counterclockwise. If channel 1 of the timer goes high before channel 2, the rotary encoder starts counting upwards. And then if it happens that channel 2 goes high before channel 1 does, our rotary encoder then counts downwards. So if you go back to the IDE, we see that the encoder mode is currently set to TI1. So we're just going to change this so that we can have both TI1 and TI2. We need to change the counter period. So I'm just going to set this value to 65535. For the polarity, we're just going to be using the falling edge, but it should work with the rising edge as well. And then for the input filter, I'm just going to set this value to 10. This is to filter out the noise from our rotary encoder input. We're going to be reading our counter values in the main while loop, so we don't need to enable the interrupt for our timer. But if you'd like to use the interrupt to read the counter values to get a slightly faster response, you can let me know in the comment section below and then make a separate video about that. We can then go to PB3 and then initialize it as a GPIO output. This is the pin that is connected to the LED. The circuit connections are very simple and straightforward. So we see that our timer 2 channels are labeled under pins PA5 and PA1. So you just need to connect the CLK pin on your rotary encoder to channel 1, which is pin PA5 in my case, and the DT pin to channel 2, which is pin PA1. And then you just need to connect the ground on the rotary encoder to the ground on your microcontroller and connect the VCC to 3.3 volts on your microcontroller. Then click on S and generate the new code, and then click yes to switch to the new perspective. When we get to the main C file, we need to initialize a few variables. So scroll down to where it says user code begin PV, and then say uint 32_t. We're just going to call the first one raw counter. This is the variable we're going to use to read the raw values from the rotary encoder. And then I'm just going to copy this and then paste it here. The other one that we're going to use, we'll just call it counter. Then I'm going to paste it again, and then this other one that we're going to use, we can just call it last_counter. And then the last variable we need, we're just going to call it blink delay, and we're going to set it to a value of 200 milliseconds. This is going to be the default delay time. So here in user code begin 2, what we're going to do is that we're going to start the timer in encoder mode. So we're going to say HAL_TIM_ E for encode, and then hold on control and space. And then we see that there's quite a few options that we have to start our timer in encoder mode. We can start it the normal way, or we can use direct memory access, or we can start it as an interrupt. For this video, we're going to use the normal one since we're going to read our encoder values in the main while loop. And then here for the channel, we need to specify the timer channels that we are using. And remember, we're using both channel 1 and channel 2. So you can just go here to drivers, and then here under HAL driver, expand the SRC folder, and then double click on this one that says HAL_TIM.c, and then you can just click on Control and F, and then you can go to the main C file, and then you can just copy this function here and then paste it in here, and then scroll down until we get to the channel parameters. So we see that we can either select channel 1, channel 2, and if you want to select both the channels, we need to use TIM channel_all. So we're going to copy this one, go back to the main file, and then we're going to put here where it says channel. Then we can go to the main while loop, and then here under user code begin 3, we're going to read the raw encoder count value. So we're going to say raw counter is equals to __ HAL _ TIM_get, and then hold on Control and space and double click on this one that says counter. Then we're just going to copy this, put it inside the bracket, and then we can just build our code to check if there are any errors. Then when it says there are no errors, we can just click on the debug button, go to the debugger, click on ST-Link, click on scan, and then click on apply and click on OK. Then here under live expressions, we need to add the raw counter variable so that we can monitor it. To add a new variable, just click on add new expression, then you can type the name of the variable that you would like to monitor. Click on the resume button, and then we see that we're currently reading 0. So I'm just going to turn the normal rotary encoder, and we see that we can read our values as we turn the rotary encoder. So what we need to take note of here, we can see that every time I turn the rotary encoder, the raw counter value increases by a count of 4. Stop the debugger and continue to write the rest of the code. The rotary encoder that I'm using has only 20 clicks for one full revolution. So we saw that our counter value counts from 0 all the way to the counter value that we added when we were initializing our timer, which is 65535. So we need to limit this value to the 20 clicks that we actually have on the rotary encoder so that our values do not overflow. So what we need to do is that we're going to limit it to a range between 0 and 20. So I'm just going to use the second counter variable and say counter is equals to raw counter variable divided by 4, since we saw that our counter increments by 4 every time we turn it clockwise or counterclockwise. Then I'm going to take this value and say %21. Okay, then now we can write the logic to control how fast our LED blinks according to the counter values that we're getting from our rotary encoder. Before we can do this, we need to write the logic to only update the blink delay if the encoder value hasn't changed. So we can just write an if statement and say that if counter is not equals to the last counter, we then need to map the delay values to the counter values that we would be reading. So we're going to blink our LED in between 10 milliseconds to 1000 milliseconds. So we're going to say blink underscore delay is equals to 10 and then counter, then I'm just going to add a percentage and say 100 and multiply it by 10. Then we need to update our counter values. So I'm going to say last counter is now equals to counter. We then need to toggle our LED based on the blink delay. So I'm going to say HAL GPIOB and pin underscore 3. Then we're going to say HAL underscore delay, and then we're going to take the blink delay and put it inside of here. Then we can build our project again to check if there are no errors. And we see that there's one error here that needs to be fixed, but shouldn't be too hard. I just need to add a plus sign here, and then we can build our project again. And then once the project says it has finished building with 0 errors and 0 warnings, we can then upload the code to our microcontroller. When the code has been uploaded, we see that the LED starts blinking at the default 200 milliseconds delay that we have. And then when I turn the rotary encoder to the right, it starts blinking fast. And then when I turn it to the left, it starts blinking slow. This is within the specified range of 10 milliseconds to 1000 milliseconds, which is 1 second. If you found the video helpful, please subscribe to the channel. If you also have any feedback or any questions or any video suggestions that you'd like to see on the channel, please let me know in the comment section below. Also, if you'd like to help the channel grow to get more components and equipment for more videos like this, consider checking out the PayPal donations link in the description below. Thank you so much for watching this video. I will see you in the next upload.